Good enough. Okay, howdy. From the 403, I'm Mr. Nelson in Hazelton. My Hazelton peeps. What is happening? Okay, last video where I was wearing the same thing, we talked about completing the square. Okay, and the completing the square got us from general quadratic form, general form, and it took us to standard form. Standard form. Now, why were we doing that? Well, we were doing that because standard form tells us a few important qualities. Most notably, it tells us the location of our vertex, which is at PQ, and it tells us, most importantly there, but it also tells us with this A if we're up or we're down, right? So it tells us if that vertex, if this is positive, then we're going to be in a shape like this, so our vertex will be a minimum. And if this is negative, if this A is negative, we open downwards, so our vertex is a maximum. So, let's do some word problems. So let's do some problems where we have to find a minimum or a maximum. Okay? Let's start with the most basic. So let's say the difference between two numbers is, let's say, 6, and their product is a maximum. Just 1 second, somebody's at the door. Your stuff? There you go.
I'll leave those in here.
Okay. Hey, thanks, buddy. Okay, I gotta skip. Sorry, guys, and the product is a maximum. Let me just make sure that that's right. Product is a minimum. Is a minimum. Okay, what are those two numbers? What are they? So the first thing I know is the difference between two numbers is 6. So the hardest part of word problems around completing the square is not actually completing the square, it's figuring out the formula, creating the quadratic. So in this case, they've given me two pieces of information. First, the difference between two numbers, let's say those numbers are A and B. The difference between those two numbers, A minus B, is 6. Okay, and their product, P, is equal to A times B, okay? And we know that the product is a minimum, A times B. Now, this P is kind of like a function. It's a function P as a function of A, of one of our numbers. So if we want to do P as a function of A, well then I have to turn B in terms of A, or A in terms of B. Let's do let's just do it this way. So B, if I move over here, so negative B is equal to 6 minus A divided by negative 1, gets rid of the negative, divided by negative 1. I get B is equal to A minus 6. Hold on 1 second. Oh man, everybody wants a piece of me right now. Okay, B is equal to A minus 6. So now in this formula, every time I see B, I'm going to throw in this formula A minus 6. So I get P minimum, my minimum product, is equal to A times B, and B is A minus 6. So this gives me my P min if I multiply it out, is a squared minus 6a. Okay? There's my quadratic, and I'm going to complete the square on this guy. So, I get P min is equal to a squared minus 6a, and then there's an invisible 0 here, right there. So I get, now I complete the square on this, so P min is equal to a squared minus 6a, and then 6 divided by 2 is 3, and 3 squared is 9, so plus 9 minus 9 plus 0. P min, now I group this, that gives me a minus 3 squared minus 9 plus 0, so this, my P min is a minus 3 squared minus 9. And so in this case, P min is like my y, and a is my x. So I know that P min is going to, with my vertex, this tells me my vertex occurs at P is equal to 3 and then negative 9. So that tells me that I have a minimum when x is equal to 3, and that minimum is negative 9. This is my minimum product. P min is negative 9. And it happens when a, which is my x, is equal to 3. So I can change that to a is equal to 3. So if a is equal to 3, well then b is equal to 3 minus 6, or negative 3. So those are those two numbers right there. A is 3, b is negative 3 for a minimum product of negative 9. Okay? So if I told you that instead of the difference, the sum of two numbers is 6, or we could say we'll say is 10, and their product is a maximum. If this was the problem I asked you, well again, I have two pieces of information. First, the sum of two numbers, a plus b, is equal to 10, and the product is equal to a times b. Well, I'll choose one. A is equal to 10 minus b. Okay, so every time I see a in here, I'll replace it with that. So my p max is equal to a, is equal to 10 minus b times b. P max is equal to 10b minus b squared. P max is equal to negative b squared plus 10b. Circle it like that. Now I complete the square on this to figure out what my P max is. So, completing the square, I got negative b squared plus 10b plus an invisible 0. Who cares? Okay? So P max, now I don't want anything in front of my b squared term, in front of my squared term. So I'm going to pull out a negative. And this leaves me with b squared, negative times negative 10b gives me positive 10b. Negative 10 divided by 2 is negative 5. Negative 5 squared is plus 25. I can't just add a plus 25 without adding a negative 25, because there I'm adding a net 0, plus 0. So I get P max is equal to negative b minus 5 squared minus 25 plus 0. And then I'm going to distribute this negative in here. I'm going to multiply it out so I don't have this bracket. And I get P max is equal to negative b minus 5 squared, negative times negative, plus 25. And here's my equation. And so what does this tell me? Well, it tells me that my vertex is at b is equal to 5 and 25. So my max, my y, is 25, is q. So my p max, my maximum product I can get, is 25. And it happens when b is equal to 5, where b is equal to p. Here p is 5. And if that's the case, then 10 minus b, a is equal to 10 minus b, from over here, 10 minus b. So a is equal to 10 minus 5, a is equal to 5. Five times 5 is my max 25. Okay? I feel like I did something wrong here, but I don't think I did. This looks right to me. Okay, so this is like our first set, completing the square with just number optimization. So the next round we'll do a couple with regards to area and perhaps something around grid. So give me a chance. I got something to do right now.